right, we are doing AP review. This is 2006 BC free response number 5. So we're given a differential equation, dy dx equals 5x squared minus 6 over the quantity y minus 2 for y not equal to 2. Before we move on, first thing we should recognize is this is a non-separable differential equation. You have x stuff added to y stuff and it can't be factored. The reason I mention that is it means you cannot possibly be asked to solve this diffie-q. You can be asked to verify if a solution works, you can be asked to derive this diffie-q, but you ahead of time know you cannot be asked to solve it. Cool, moving on. Part A, evaluate dy dx and d squared y dx squared at negative 1 comma 4, which is the point that we were given. So you can, before you do anything else, you might as well plug in the negative 1 and the 4 and just find dy dx at this negative 1 comma 4. So that's the easier thing to do, so I'm going to start with that, right? Pick the low-hanging fruit first, right? So dy dx evaluated at the point negative 1, negative 4 is going to be a 5 times a regular 1, because it's a negative 1 squared, minus a 6 over what seems to be a negative 6. So that's a 5 plus a 1, and I get a 6. So that's the first thing, and it's worth 1 point. Yay. The second thing I'm going to have to do is find the second derivative before I can plug in the value. So d squared y dx squared. When I derive the 5x squared, I'm going to get a 10x. When I derive this guy, I'm going to need a chain rule, right? Because this thing right here is actually secretly a negative 6 times a y minus 2 quantity to the negative first. So when I derive this, I'm going to drop the negative 1 down and get a plus 6 y minus 2 to the negative second times a dy dx because I just derived some y stuff. So I'm never actually asked to find d squared y dx squared in terms of x and y, so if I were you, I would leave it like this, right? Or if you want to make your life slightly easier, I'd probably make it a 10x plus this 6 over a y minus 2 quantity squared times a dy dx. The reason I mentioned that it's not worth finding this in terms of x and y, I mean, you can certainly plug this whole thing in for this dy dx, but they didn't ask you to do that. And they just want you to evaluate d squared y dx squared at negative 1, 4. Well, conveniently, I can plug into this stuff, but I've already evaluated this piece at negative 1, 4. It's a 6. So if I were you, I would just go ahead and plug in and say, okay, this is a 10 times a negative 1 plus a 6 over what seems to be a negative 6 quantity squared times what seems to be a 6, because again, I want dy dx evaluated at that point, and that's a 6. So I think that when I clean this up, I get that this is a negative 10, and this seems to be a 36 over a 36. So I think that's a negative 10 plus a 1, and I just get negative 9. So when you look at the points here, you got 1 point for evaluating dy dx at negative 1 and negative 4. You get 1 point for finding d squared y dx squared, but not in terms of x because they didn't ask you to, or in terms of x and y, right? And then you get 1 point for finding this answer. So that's a 3-point part A. Cool. Part B. Is it possible for the x-axis to be tangent to the graph of f at some point? Explain why or why not. So f is the solution to this diffie-q. So they want to know if the x-axis could be tangent to this curve, right? So for the x-axis to be a tangent to the curve, right, what they're saying is that you'd have to have a horizontal slope when y equals 0, right? That's what this is saying. So let's put those pieces together. So part B, if x-axis, right, which is the line y equals 0, is a tangent to f of x, that gives us 2 pieces of information. Piece of information number 1, we would need y to equal 0, and at the same moment, we would need dy dx to equal 0, because that's how you have a horizontal tangent, is if your dy dx is 0. So those are the 2 things that would have to be true simultaneously. The question is, if we plug in y is 0 and dy dx is 0, do we get something that's physically possible? And if the answer is yes, awesome. And if the answer is no, awesome. So, so let's try this, right? If I plug in dy dx is 0, I'd get 0 equals 5x squared minus 6 over negative 2, right? So I end up getting, I would end up getting that this becomes a positive 3, right? So I end up getting 0 equals 5x squared plus 3, right? That's never ever going to happen, right? The reason that's never going to happen is that 5x squared plus 3 is always positive, right? this thing is greater than 0. The way I can tell it's greater than 0, there's a bunch of ways. 5x squared, the smallest that could possibly get is 0, and then you're adding 3 to it. You could also tell by looking at it visually. It looks something like this, right? 1, 2, 3. It's up 3 units, and it's a parabola. It's never going to equal 0. So that's not possible. So no, 5x squared plus 3 doesn't equal 0. So it's not possible. So to get your credit, you needed to use this piece of information and this piece of information. So that together was worth 1 point for the AP. And then you had to give an answer and give your justification why, right? Cool. All right, so part C. Find the, here we go. Now we've got some calculus that's BC. Find the second degree Taylor polynomial about x equals -1. All right, cool. So here we go, finally some BC. So we get to part C, and this is a BC topic, which is why it was on the BC test and not the AB test. So they want the second degree Taylor polynomial, so they want P sub 2 of x, right? So what that's going to be, right? That's going to be essentially f of, they want about -1, right? F of -1, right? Plus f prime of -1 over 1 factorial, so we can just ignore it, x minus a -1, so plus 1 to the first, right, plus, oh, I did not give myself enough space, f double prime of -1 over 2 factorial times x plus 1 to the second. Let me inch so you can see it, because I did a bad job. All right, cool. So that's what I want, right? That's the definition of this Taylor polynomial. Well, we actually know this stuff, right? We know that f of -1 is a -4. That was given, right? You found dy dx evaluated at -1, -4, which is totally what this is, right? So this is from your part A. You found that it's a 6, right? This was found in A, right? And then you found this guy, right? You found d squared y dx squared evaluated at -1, 4 in part A. It was a -9, right? So, again, that was found in A. So when we put all of our pieces together, right, we get that our second degree Taylor polynomial, if I adjust a little better, P sub 2 of x, should be a -4 plus a 6 times the quantity x plus 1 minus 9/2 times the quantity x plus 1 squared. That's your second degree Taylor polynomial. Cool. So part D, so that was BC. I think part D is probably the other thing that we can expect from a Diffie-Q on a BC question, which is probably Euler's. Yep, part D. Use Euler's method starting at -1 with 2 steps of equal size to approximate f of 0. Show the work that leads to your answer. So people do Euler's in different ways. The way I personally do Euler's is as a table. It just makes more sense in my brain. So remember, and I think we've talked about this in other videos, that Euler's is essentially just a point-slope form, right? So I know the slope is this horrible, ugly mess. -6 over -2, right? And then remember that point slope is y minus the y value equals mx minus the x value. But you could call x minus the x value, sorry, inching again. You could call x minus the x value just delta x, and you could add that over. So my y new is m times the change in x plus whatever my old y was, right? And that's the way I do Euler's. And you don't have to do it that way, but it works for me. So I know the point -1, 4. I'm asked to get to 0 in 2 equal steps, which means this is going to be -0.5 and this is going to be 0, right? It means that my step size is a positive 0.5, right? So my delta x is a positive 0.5. So in this case, this is a positive 0.5, right? I know the slope. I know dy dx at -1 because I already found it, which is great. We found dy dx at -1 and it was a 6, right? So I'm going to get that my y new is 6 times this 0.5 plus, oh sorry, I made that a positive and it's a negative plus a -4, right? So that's a 3 plus a -4, which means I get a -1. So that's my new y. And then I do the same process all over again. Now this is the part that gets a little bit icky and nobody likes it. So when I plug into this guy, right, and you might decide that you need some space to get this ugly monstrosity, right? This is going to end up being 5 times a half squared is a 4th, right? So that's going to be 5/4 minus, this is going to be a 6 over a -3. So I end up getting this as 5/4 plus 2, right? So I get 5/4 plus 8/4. So I think I get 13/4, right? So I get 13/4, which is going to matter over here. So that means that my y new, which by the way is my final answer because that's the y value I want, is going to be my slope, which is 13/4 times my 0.5 plus my old y, which is a negative 1, right? So it's up to you. You might find it's easier to treat this 0.5 as a half, right? So this is a 13/4 times a 1/2 minus, I notice this is going to end up over 8, so I just make this 8/8, right? So I get 13/8 minus 8/8, so my answer is 5/8. So 5/8 is my answer to the question, right? I got to what my approximate value for f of 0 is, right? So when you do Euler's, they're going to give you points for doing it twice, even if you screw something up. So one of the points was for the answer, yay, 1 point. But the other point was that you did 2 rounds of Euler's, and congratulations on you. They understand there's a good chance that this comes out wrong because you add wrong and tragedy happens. AP Calc students are inexplicably more likely to add wrong. So